And we are live. All right. Oh, we're live. Let me just open these and post about it. Changed my plan. So post these. This is part one. This is part one. Yes. All right. Perfect. All right. So what are we doing? What are we doing? What I'm doing is the following, right? I'm gonna start this. This kind of started a bit as a not a joke, but like I saw Yasin on X basically saying, oh, he's learning PCB at the moment because he needs it for his startup. And I thought, like, I mean, I don't need it right now, but I what I want to test is I wanted to have an excuse and a real case scenario to actually use openLesson. If you've been following the project, you know what openLesson is, but if not, I'm gonna give a few minutes, not a few minutes, but like what's the one-liner of openLesson? openLesson is it's a tutoring harness or a learning harness, right? So this is not like a Duolingo or a Brilliant.org. Like, this is not an app that is going to generate like learning content for you. This is an app that is going to it's implementing a learning loop. You will see that now, the way that the way that this works in action. But what I'm going to do is I'm going to be so you can create plans and whatnot. I have already created one because I could also just drop a YouTube video or whatever. I've created one earlier before the stream, but essentially just drop the topic here, say how long do you want to roughly be learning. And then I have one here, so I just have tons because I'm testing a lot. This is in beta test, by the way. If you want to test these, just let me know. And we have plans. We have the PCB design plan here, which it's public, and you can go and fork if you want to. But the idea is that's the plan, and that's just like here you see the sessions, or you see sort of the sessions that we're going to be working through, and you don't really have to go through these like in a row. We're not trying to be like the AI provider. No, we're not trying to be like the app that designs the course for you. That is, in my opinion, that is really suboptimal, or it's not really leading to any improvement. Because it's not really gonna, you're still spoon-fed the content, right? The whole point of learning is that you have to actually work. So anyway, and I'm gonna be using this because I think PCB is especially like a good example where there's gonna be something where we're gonna be needing external tools, and so there's quite some stuff to test here. Or to put the system to test. Okay, again, we are still in beta testing. I really want to roll these out or launch these in the next day or two, but I'm still sort of polishing some of some nasty bugs and whatnot. But we will start from this session first, and you will notice that I'm just gonna go straight and start the lesson. And while I was preparing the session, you'll notice that I have my Muse band here. It's because I'm gonna record my EEG signals as well. This app is basically registering that also, right? So it's part of the way that this works. It's optional. You don't have to use that at all. I'm gonna turn Bluetooth on because that works with Bluetooth. And yeah, cool. Okay, perfect. So let's wait until the app gets the lesson gets started. Essentially, what's doing is it's preparing for you the plan and whatnot. And so the way this works is like that. Welcome to your session. So the tutor has prepared the personalized plan. And again, it's not a content. Maybe I have to change the wording. It's not about the content, right? This is not going to tell you read these and whatnot. It's basically going to it's going to control your learning loop. You have to let go. It's going to control your learning loop, and you have to let go and follow the tutor, right? So you press start the session, you follow the session plan, and use the guiding questions to advance. And then there's a bunch of tools built in here that we can use to help us think out loud. The whole point of these is you have to think out loud. Okay, so this is not gonna be, if you're like, if you want to sit in the couch and read about quantum computing, or PCB design, you're not going to learn You're not going to learn anything about PCB design if you're just going to sit in your couch and read shit. We're here to actually do real work. That's the way this works. That's why we're controlling. This is the loop. We're controlling the loop. Okay, so we're going to get started. So what we have is this. We have our student monitoring, and we have already the plan. So what is the plan? The plan for today is the following. So we've got the goals and whatnot, and then the goal of the session is, by the end of the session, the student will understand the basic components and functions of a printed circuit board, be able to differentiate between single layer and multi-layer PCB designs with some real world examples, and apply these concepts to identify potential issues in a simple PCB schematic. So I guess we're going to learn about even what a schematic is. So what we're going to do is we're going to basically follow these. And again, it's not, if you know, this is going to be I'm probably going to do 30 minutes or something like this, or 30-40 minutes. It's not a bad idea, actually. You know what? It's not a bad idea to document a few feature ideas or bugs in here as well, features and bugs. Because what I'm going to do is, I think it's not a bad idea to feature sort of like plan hard stop or pause. You know what I mean? That I'm like, I wanna spend like 30 minutes, right? And then it's gonna basically, because that's a good idea. Anyway, let's get started. Let's get started. We have the plan here for the session. We don't have to go. I don't know if we're gonna go through all these today. That's just a plan. You can read through these. You can regenerate it if you don't like it. So first we're gonna be talking about what do we already know. Okay, so let's start the session. We have a teaching assistant here. We have a canvas to draw stuff, and we have some notebook to take notes. But that's like, and some sort of practice and theory. So we can use the tools on the left whenever we want. That's going to generate some theory for us if you're the kind of person that wants to read something before jumping into answering these questions. But the current question is this one. We're going to be focusing on this question here, which is, by clicking it, I'm actually focusing on these, right? So what is a PCB? A printed circuit board. I didn't even know that. Okay, that's good. Oh, and by the way, first let's connect these. Let's data input. Let's connect news. I have to turn it on. Is it blinking? Wait. Yeah. We're gonna connect news. That's just it's advanced. You don't really have to use these. I do this because we're sending this to the LLM as well to train later. So you don't really have to use though. And you could also turn on the camera and do face analysis. But we're just gonna do Muse today, and obviously the audio is all the time there. Okay, perfect. So this is done. So we'll go back to teaching assistant. No, we'll go back to theory, and it shouldn't reload actually. Theory shouldn't regenerate. Should stay. Anyway, so what do we already know about printed circuit boards? And can you describe a simple example from everyday electronics? Yes, I think, a PCB is basically, so the way that I know these is, I guess it's just like a cheap thing, right? It's like, okay, cool. Yeah, it's basically a cheap, right? Well, that was maybe a little too, like, I got scared actually. I'm testing some of this new game dynamics, okay? So the sound effect for completion, too scary. But it's good maybe. Okay. Okay, so we're jumping to a task. We're done with this. It's fine. We know what the basics are. So the task at hand is, and I'm gonna slow down a bit. If it's too much, you can always pause this. It's all good. It's just, we'll resume. Anyway, list and briefly describe the basic components of a PCB, such as traces, pads, and vias, based on what you've recalled or researched. Okay, so we're gonna be doing some research then, because I don't really know any of these. I could copy that. I can just ask the teaching assistant. Or maybe let's so what is a PCB? Printed circuit board is a flat board made of insulating material with conductive pathways. These are, I guess, the paths etched onto it to connect electronic components. It serves as the backbone for most electronic devices, providing mechanical support and electrical connections without the need for wires. This is the interesting part, right? So essentially, you're not really wiring anything. What you're doing is you're isolating the things where you don't want electricity to go through, I think. And I think that's the way these work. So let's briefly describe. Let's try to describe these basic components. Types of PCBs. We have single-sided and basic components. So we have we have here some basic components that listed. So the substrate like fiberglass, copper traces that act as wires, pads for component attachment, and vias for connecting layers. I don't know. So what are vias and what are vias in the PCB, first of all, and for connecting layers? Like, why do you even need to connect layers? Ask the assistant. Yeah, that's kind of okay. So it confused me most about how traces connect the pads on a PCB. I mean, these yeah, that's exactly that's exactly it's a good question actually. So this is really like it's so the question here is the guiding task in question is like what confuses me the most. Well, that's exactly what I asked. That's it's good timing. That's exactly what I asked. This whoa. Okay. So great question. Simply put, a via is essentially a small drilled hole. Oh, so the vias are the holes. I didn't know that. That's nice. So drilled a hole in the PCB that's plated with conductive material like copper to create an electrical connection between different layers. That's why they have. That's why they have. That's why they have walls. Okay. Oh, you see. Okay, cool. So that is actually a bug that I'm still. I still have to fix before. I still had to fix. We'll just continue with the questions. I hope I need to fix that because it actually kills the plan and it shouldn't kill the or it somehow. Let me see if I can pause and I just reload if it's actually going to reload. If it's actually going to fix it. So the plan. So after completing a task or step, the plan breaks empty steps. I think that is just a rendering hiccup. But I was basically yes, I was basically listing the vias pads. Okay, so I mean, are these all of them then? I guess that's good enough. I didn't know that. I didn't know that the vias are these holes, and now I understand why these holes exist. So these holes connect layers, but I still don't know what these layers are really for. Let me just I'm just gonna reload now. I have the session paused. I'm gonna reload. And I'm gonna have to reconnect these, I guess. But let's. I just want to see if it's just a rendering issue or it's really a database issue. Because it should actually remember the plan, and I think it's really a fucked up issue. Yeah, I think it actually messed it up completely. I need to probably add a way to fix that because if I regenerate the plan, it's gonna go from scratch. But it's fine for now. Let's continue. Let's continue with this. Oh, and it also messed up the question. Anyway, we'll continue. We were talking about the we were talking about yeah. So you see, these are the things that that's why I'm doing these sessions because I want to fix these little things. It shouldn't happen that that the plan gets kind of like empty and whatnot. It seems like you're passing, yeah. Okay, so we're starting from okay, now it's a little different, obviously. But it's fine. So we already know about printed circuit boards, and can you describe the primary purpose of electronic devices? Yes. Let me resume these and let's basically go and reconnect that data input. So I have to fix that back for sure. We'll continue. I mean, we will try to actually. What I'll try to do is I'll try to go back to where I was. But yes, essentially, no, I'm not puzzling about the flows. So I already know what I already know about PCBs are that we have different layers, we have the vias, we have different components like the pads for connecting for connecting like you know, whatever the connectors and stuff like that. We know what the purpose is, or the concept of PCBs is that you don't use cables. It's like an integrated board where you basically just have, I think, isolated materials that basically, you know, you rather do the opposite where uh, you're actually telling the the board where the electricity shouldn't go, so that it, you know, you're drawing the in a way you're drawing the cable, like they're not cables, but like you leave conductive areas uncovered so that they become, then, you know, they behave like cables, right? That's the, I think that's the idea. I'm definitely not passing over this, bro. So yes, perfect. Okay, cool. A simple sketch of what you think a basic PCB looks like, including any components you can recall. Well, that is what. So this is what. And by the way, tasks should have a little. This is a feature first. So tasks could have input, but that's for later. Like upload and whatnot. So essentially, the way that I imagine these is, you just have. So, I mean, how it looks like. Yeah, I know how it looks like, right? It just looks like, you know, you have the board, and now I know that those holes, what they're doing, those little holes you can see sometimes on the board. If I were to look at the board from sort of that angle, what is happening is you probably have multiple layers, and we're going to draw them like these. So one is red and then another one is blue. I'm just making it up, okay? But you have multiple layers. And so essentially what the hole is doing these, right? It's kind of like it lets the electricity, let's imagine here is the conductive material. It lets the electricity go down here, maybe, you know, follow this path, for example. This is awful. What I'm actually drawing here is pretty awful. But so you get a feel, right, of what's happening. And I think that's the, you know, then you have obviously on you kind of connect, you know, things like a USB port. You can connect like LEDs. You can connect things like these, I guess. I think that is the point. What am I confusing about how components connect? Nothing really. So I wouldn't say nothing confuses me how these things connect, because I think the way that this works is basically like this. It's like you have. So let's imagine. Let's clear these. Let's imagine you have this board, and you have one component here and another component here, right? So you're not really building a cable. You're not like laying a cable. What you're doing in reality is and I'm making it up. Maybe that's not the right thing, but I think that's what's happening. You're putting here a piece of material that is not conductive, right? And one here that's not conductive, right? And that is actually drawing how the electricity moves, because that's the only place electricity can go. I think that's the way this works. Okay, so what components am I missing in my PCB sketch that would make it functional? Well, I guess it needs electricity, but I don't think that's part of like what we understand as a PCB design, right? What are the components? We have input and output. You know, we have input and output. Well, not input and output, but we have connectors. So we have things. Like, I don't know. What I don't know is why would there be more than one layer needed, beyond the fact that you maybe can have components on one side and on the other side. So I have no idea. Maybe there's something related to physics. You know, I just don't know. I guess those components do things, right? So you might have components like memories or like whatever. I don't know. I have in mind, you know, if I have in mind things like a chip or whatever, you know, you kind of have like a PCB. I mean, just go to Google and do PCB, right? I mean, I think it's any of these. will show you these components, right? And so you see the green thing here is what I mean, right? So then you have the cables. I think that's the way the best way for this to be explained. I think. I think I'm done with this task. What else? Draw a simple sketch. Oh, you see it fucked it up again. Okay, guys, it's gonna be unusable for today. I have to fix that before I continue. But I'm gonna start. I'm gonna continue for the rest of these. I'm gonna do like 10 more minutes. Did I connect Muse finally? I did connect Muse, right? Yes. Okay, so I'm gonna do a bit more of self exploration on these questions, and then I'm gonna go back at fixing this because this is fucking annoying. We haven't really moved a lot, so let me just regenerate the plan anyway. But before we dive deeper into your PCB sketch, let's clarify the basics of electric current flow. Think of traces as predefined paths, like roads in a city, where components like resistors or capacitors directed traffic or current according to the circuit design. Really? So how components like resistor. Let's clarify the basis. So how do resistors or capacitors direct traffic on a PCB? I mean, that's a good question. Like electricity. Like these are not. There are no real cables, right? There are no real cables. So I think that's No, I don't want to pause the session. You're being too don't pause the session. You're being too sensitive about it. Cool. So, okay, let's read through these a little bit. So there's a great question. Love how you're thinking about PCBs in terms of traffic. It sounds like you're using a metaphor. Yeah, that's what you gave me. Anyway, no cables needed. So you're right. PCBs don't have bulky cables like you might see in a wiring harness. Instead, they use copper traces, super thin, flat strips of copper etched into the board. These act like that. Okay, so they are really etched. Actually, they actually really. I thought they would do. These act like tiny highways. Yes, no real cables means everything is compact and integrated. Signals are the cars, blah, 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 blah. Okay, you're being too. How resistors drive? Don't exactly drive the traffic. They're more like traffic controllers. Their job is to resist or limit the flow. Yes, I know that, but how do they do this? In a LED circuit, it prevents the LED from burning out by limiting how much current flows through. Yes, that makes sense. Why it matters on a PCB? Without resistors, signals could crash and overload, so they yes, that makes sense. Why haven't there's no resistor in a high? Yeah, that makes sense. Analogy. A capacitor is a parking lot for traffic light. It can hold cars. It can hold a charge temporarily and let them out in a controlled way, smoothing out traffic jams and sun surges. Okay. So at least we've learned that capacitors control or make the flow of electricity smoother. On a PCB, resistors and capacitors work together, blah, blah. Yes, but how? So, how would you, so how do you physically embed a resistor, right? And I do have a few questions here. Let me see what I have. Well, let's wait. Let's finish these first. We're full anyway, right? So this here at the top tells me there's we it's not gonna ask me more questions. We need to kind of focus on this before we want to progress. That's a bit slow actually about these. And it's two verbose. Definitely two verbose. there are two common methods: through hole and surface mount. SMD. So let's break them down. Through hole, the classic way, it's like poking a component through the board and securing it from both sides. Great for beginners or prototypes because it's straightforward. Prepare the board. Wire-like legs will go. Oh, so there's actually really, you put them in vias? You really put them in the holes? I can't believe that. Really? So what's it called? This is called SMD, surface mount. I want an image. I can't believe you. Do they really go? It just seems like soldered. This is not like these. Yeah, I mean also. But okay, yeah. And then what are the other ones? So the other ones are surface mount technology. What did it say? Through hole and surface mount. Oh, so through hole are holes and surface. No, I want through hole. I want to see a through hole. That's what I want to see. I want to see a through hole. I don't. Oh, really? It actually works like this. Okay. Yeah. All right. Perfect. I didn't know you can do that in the PCB design as well. Okay. That's fine. Cool. I mean, let's just look at these first. And I have to say, this design feels a little too compact, to be honest. Hard to kind of follow through all the questions, but whatever. So I think some of these are easy, but let's answer them, right? So what components am I missing in my PCB sketch? No, let's not focus on this one first. Let's just focus on the, I mean, this is an easy one. So the main job of a PCB in connecting electronic parts, well, it's just connecting, right? It's the circuit itself. It's like in a way, I guess the concept of the PCB is, and what is stand for again? So I guess the concept of PCB is then it's just the job is just basically connecting electronic parts. It's just it's just a circuit. It's a printed circuit. Yeah, it's a printed circuit, right? I mean, it's basically interconnecting the electronic parts. So that is the thing. I'm not so sure I understand the question. So we'll just get rid of this one. Get rid of this one. What role do vias play in PCB sketch? So we talked about this later, for connecting components across layers. I'm not hesitating. What am I hesitating about when recalling the main purpose of PCB? Nothing. These questions, I'm not happy with these questions. They're a little too Socratic. I have to work on these. I think the prompt for that is a little shit. Questions are a little too Socratic. We should move on. I should be able to just move on. I'm not hesitating about recalling any. I mean, the purpose of the PCB. Yes, I did. Sure. The purpose of a PCB is that. I mean, isn't it? I mean, what's the purpose of a PCB? What's the purpose of a PCB in regards to these? Sorry. Let's just do clear chat history. So what's what happened? Oh, did that break? Did the clear break? Actually, the assistant? No. Okay. Perfect. I don't want to. It actually re-rendered everything. Okay, so that's a back, definitely. Clearing TA convo. That's it. Yeah, those things are sometimes tricky, right? So I've been now running these for 15 minutes. And so Oh, how that goes. Anyway, where were we? Before we get deeper into your PCB sketch, let's clarify the basics of electric current flow. Think of traces as predefined paths like roads in a city. Yes, I think I understand that. That is fine. I guess I'm not moving forward because I'm not moving forward with the plan because I fucked up with the plan. But what do you already know about printed circuit boards, and can you describe what you think their main purpose is? The main purpose of PCBs is, yeah, man. You know what? I should just be able to skip these. Although that is indeed kind of cheating, as in like, because people are gonna speed run these, and that's not the point. So now, right now, it's gotten into a situation where I feel trapped in here because I'm full of questions, and I'm not progressing because I messed up with a plan. And essentially, I messed up with a plan, and so makes me start from scratch. You know what I mean? So this is definitely a situation that I need to avoid before going live, because this just gets messed up and then you get peace. But I mean, let's take a step back. Okay, so what do you know already about printed circuit boards, and can you describe what you think their main purpose is? So printed circuit boards are basically those pieces of those boards where we put in components on them, and essentially these components are connected via the pathways, so to say, which are not really cables, right? So they're like, I mean, are they really like? Because I think the way they are manufactured is really like you have a layer of copper, and it actually you really are isolating the, you know what I mean? Like you're drawing the negative. That's what I thought. That's how I thought they were built. They were built like these. And so their main purpose is just to print circuits. It's just electronics. It's really just electronics. So fuck these. The role of vias in my PCB sketch or in PCB sketch for connecting components across the layers is basically these, right? So you want to maybe sometimes reach to other places. Maybe you have like a two-sided board. I think that's the way this works. You just have a two-sided board, and then you want those things to be, or maybe not even these, right? I mean, it's even like I think it's even also the fact that sometimes maybe you want to skip a component in between, right? So maybe you want to have something like this. That's maybe an important aspect of the. Let's say you have the board, right? And the whole point here is that you have a big component here, and you're trying to connect a component from here and a component from here. And what you can do is, if you have let's draw the bias, the BS of bias, whatever the bias here. So if you have the bias here and bias here, maybe what's happening is you go here, then it goes underneath, right? Then it goes up again, and then here. You know what I mean? Maybe. I don't know. Maybe you kind of like you have multi-layers because of how complex the design is. I don't know. What components am I missing in my PCB sketch that will make it functional? To be honest, I don't know. Let's ask the TA. So what are the components that we need on the PCA to make it functional? Let's learn that. So apparently I'm missing something more basic. That's good. The thing is, this system really it really forces you to think about stuff, right? It's like sometimes you just want to go fast, and maybe I'm just missing something very basic. So what? Okay, so what do we have here? The PCB itself is just a blank slate. 4 categories of components. We have power sources. And we have passive components for traffic, like the traffic managers. I guess these are the resistors, the capacitors, and stuff like these. Active components, which are processors like transistors, diodes, integrated circuits. Yeah, then we have connectors. Then we have connectors and interfaces, connectors and interfaces, support elements, fuses or protection diodes prevent damage from overloads. Ground planes or vias ensure proper signal return paths. Yeah, I don't think there's anything groundbreaking here that I'm missing. What components am I missing on my PCB edge? I think that would be it, right? So I mean, I didn't talk about the ground. That's why probably it's not marking it as done. I guess I know now. So I mean, you have support elements, obviously. Yes, that makes sense. Support elements, connectors, and interfaces to connect with the outside. Active components, passive components, and power sources and supply. The support elements is what I overlooked before. So this is what I overlooked before. Basically, yeah, to prevent the damage and this kind of stuff, right? So let's mark this as done. We definitely discuss the basics of electric control. Think of, yes, we know these. I mean, I know the. So this is okay. What else do we have here? So I seem to be missing something. What unexamined assumption am I making about the main purpose of a PCB? What's the main purpose of a PCB? What am I missing? What am I missing about a PCB? I think that's because basically what I think is the main job of PCB and connect electronic parts. What role do vias play? I know this. So what the role that vias play in PCB is basically connecting components, right? No, connecting layers. Sorry. So, bro, what is it that I'm missing? What is the main purpose of a PCB? Yeah. What problem does it solve? They're built with loose wires, connecting components point to point. They're tangled, blah blah blah. So the PCB is a foundation platform. Okay, so for mounting components securely, provides a stable base. It interconnects them efficiently. Those copper traces act like built-in wires. It enables functionality by doing the above. It allows the circuit to work as a whole. Power flow, signals process, device does its job. Yeah, that's the whole. That's what I mean, that's what I'm saying, right? So I think it's essentially, yes, okay, sure. I miss the main role of. So what am I? So what I'm skipping is the main purpose of a PCB is just to provide something that is more solid and stable than just like a loose fucking cable mass, right? So I think that is done. And I think so. I think it's two things, right? I think I got into a problem now where the plan is not advancing. So this is still a mess. And the problem here is the following: I messed up the plan. I think everything's like the biggest problem is the plan cannot get messed up. The plan cannot get no break. If it breaks, it just kills the experience. It kills the entire experience. If it breaks, it kills the entire experience because that's the loop. That's the main loop, you know? And the thing is, when it comes to learning, you don't want to have to repeat yourself over and over again. So we either provide a way to skip through the plan and say, okay, no, I know these, I know these, I know these. That's all good. I can I can go ahead and then skip these because then these questions that come from these from the plan essentially are all the time like around the same sheet, right? And this makes no sense. That these um and yeah, but I think essentially that's So what was the goal of the session? It's basically understand the basic components and functions. Yeah, okay, perfect. PCB schematic. Okay, so we haven't analyzed a simple schematic. But we will do that. I mean, I've definitely learned about a few things, right? The holes, the layers, the fact that there's all the support structures in there. But so far so good. I mean, I think it's simple. It's actually so far I think I understand at least the first principles of how, or at least those elements I was not really aware of. So, but yes, then definitely I have to work on the. But I think that's the point. The plan cannot break. Theory should, yeah, those are minor things, sound effect, whatever. After completion, the plan breaks, and that's the biggest one. That's the biggest one, and then we can get rid of these things as well. And sometimes these questions are very Socratic, very like philosophical, which is okay. I have to think about this. I don't know, and that's definitely one small. But the plan is the big thing. It's big feedback for me. All right, I'm gonna close. I'm gonna close it because I'm gonna try to close this session later on in another video. But that's basically for now. I'll wrap it up here for this session, and then I'll probably do something else a little later. I'll see if I can try a follow-up session, because again the plan is here, right? So I can still kind of go and jump into the session. I don't really have to complete one section. So I can actually go and start the electronic components and schematics. Learn about the components and schematic diagrams. The fundamentals. I think we've done the fundamentals, and then we can go through components and schematics. Well, I want to, at least at the very end, I want to be able to try to manufacture. Oh, guys. See you later. See you later. I think I might do another one, short one. Whoa, fuck. This just. See you later.